Can you hear me, guys? Is my screen visible?
Yeah, we can hear you and your screen is visible.
Okay.
Yes. Okay.
So today our activity is to create a security group from console manually. And so after creating a security group manually from console or website, then we are going to write automation scripting. So yesterday we have seen how to initialize a working directory for Terraform, and what are the necessary files, how to configure credentials, how to initialize current working directory. These many things we have discussed in last class. I think in the last class we have initialized one folder. So what is that folder name, guys? Have anyone remembered? It is there in my D drive. I think Terraform. Is that folder installed? This one. Terraform DurgaSoft 6th December. Okay. So this is a folder where I have written provider script. Okay, for downloading AWS plugins. And from here open git bash. And in the last class, I also discussed how to set up Terraform and what are the softwares that are required for our course. So complete details we have discussed in last class. Now this is a folder from where we are going to write our Terraform scripting. Now from here I want to open Visual Studio Code. So there is a simple command, say code dot. This is a folder where we have initialized Terraform in last class. Now, our first goal is to create a security group. So in AWS, security group is nothing but it is a set of ports to be opened. So generally, when you create a virtual machine, a new security group is created. Okay, where we are going to write what are the ports to be opened for whom. Okay, and we know that a computer system will be running multiple applications, and each and every application is identified by a port number. And if outside people wanted to access that application, you have to open that particular port number. Suppose in my virtual machine, I have installed Tomcat server. Tomcat server will be running on 8080 port number. And if others wanted to access, Tomcat application, the application developed in Tomcat, you have to open 8080 port number, so 8080 port number for public on the internet. And suppose IIS server, .NET application you have installed on Windows server, then you need to open 80 port number. So if others wanted to access .NET application, okay. So here that kind of security rules we are going to define in security group. In AWS, while creating virtual machine, automatically a default security group is created, and you can create security group separately, and you can associate that security group to a virtual machine while creating it. While creation of virtual machine also you can associate a security group. Choice is yours. First let us see how to create a security group. Now for that, let us go to AWS console, console.aws.amazon.com. Log in with your credentials. I am logging with my credentials. Okay, this is a landing page of AWS. Now here it is going to listing out all the recently visited services. On the top, you will be seeing a menu, services menu. And this is search box. Here from here, you can select any kind of service here. On the top, there is a drop down. Okay, so the drop down is going to show all the regions. Like a region is nothing but it is a geographical area, geographical location on the globe. Region will have data centers and availability zones. And while creating a resource, you have to specify region where you want to create it. Okay, so the regions are like North Virginia, Ohio region, North California, Oregon, Mumbai, Osaka, Seoul, Singapore. These are the regions. Each region is having a region code. Okay, suppose I want to create infrastructure in Ohio region. So for Ohio region, the shortcut, the abbreviation is US East 2 is a region code. North California, US West 1, Oregon. Okay, these are the 4 regions that are available in USA. And these are the 2 regions which are available in India. Mumbai. One more is in Hyderabad, there is no region presently. Okay, so this region belongs to our country, Mumbai. So this is abbreviated as AP South 1. Okay, so this is a region list. Here this is my account name. And this is notifications. And this is settings. If you click on settings here, you can change your appearance. But I am not changing. If you are interested, you can change it. Now, to create security group, okay, security group is related to EC2 service. So EC2 is nothing but Elastic Cloud Computing in AWS. Okay, so in AWS, so what are the services that are free for 1 year? Okay, so if you want to know about free services information, there is a website here. So you can ask like this: AWS free services, free tier services for 12 months. And here if you scroll a little bit down, okay, here select 12 months free. Are you seeing EC2 750 hours free, 50 GB, Elastic Container Registry 750 hours of load balancing. 750 hours means how they will calculate. Every month they are going to provide 750 hours of compute. Okay, so suppose in a day you are using a virtual machine 24 hours. Per month maximum we are having 31 days. 24 into 31. Okay, approximately it is equivalent to 750 hours. That means one complete virtual machine you can use for month long. Okay, that is only these categories only. T2 micro and T3 micro, these machines only. Okay, so T2 micro means it is a virtual machine which is having 1 CPU, 1 GB of RAM. Okay, this is about free services list. Now, to create security group. So here in services, go to EC2. Here you are seeing a option called security groups. Here, there is an option here. Under network and security, there is a section called security groups. Click on security groups. Okay. Now, these are the security groups I created for other systems. And if you want to create a security group, you click on this yellow color button on the top. So what is the security group name? My group. Okay. Or otherwise my manual group. Manual security group. Description, you can give any description for testing, and it is asking in which network you wanted to create it. Presently, we don't have any network, custom network. So this is a default network. Okay, for every region, there is a default network that is provided by AWS. I want to create this security group in the default network itself. And here, while creating security group, you have to add rules. Okay, what are the ports to be opened? Okay, so I want to open a port 22. So 22 means what is the 22 SSH? Okay, so if 22 is open from your laptop, you can connect to this cloud virtual machine. Okay, 22 is for SSH port number. Okay, so if 22 is open, you are able to connect to your virtual machine from your laptop. That we are going practically see. Okay, we will see that. And source for whom you are opening, for everyone on the internet. So everyone is nothing but 0.0.0/0. And we are going to add one more rule. This is 80 port number. 0.0.0/0. Okay, that's enough. I am adding only two rules. Create security group. Okay, security group name is my manual group. My manual group is a group name. Okay, that means while creating security group, I have submitted few details, right? So these are nothing but what arguments. While writing Terraform script, this becomes arguments. Okay. Now, while creating security group from console, what are the inputs we have given? Okay, you have to remember those inputs. Those inputs you have to remember. So what are the inputs I have given? Security group name, VPC ID, and what are the ports to be opened, for whom you are opening the port number. Okay, and what is their port range. So these are the input items that I have given while creating security group. Okay, now this is manual way of creating security group. So for the same thing, for the same activity, I am going to write Terraform script. Now to write Terraform script in our current working directory. Okay, in our current working directory. Guys, can you hear me? Am I audible? Guys, am I audible to everyone?
Yes, Shiva.
Okay. Now here, to automate this security group creation, I am writing one file. Okay, the file name will be SG. The file primary name can be anything, but secondary name extension must be .tf. And how to write script. So in Terraform documentation, loads of scripts are there. Okay, you have to search one of the scripts. So how to search for this Terraform AWS security group? Approximately, we are having more than 2000 services in AWS. Okay, every service we cannot use, every service we cannot learn. Okay, this is a AWS security group section. And just if you scroll a little bit down. Okay, so yesterday I have spoken about three types of blocks, right? One is provider block, which I used yesterday to initialize current working directory. And another block is resource block. Resource block is especially for creating resources. So resource block starts with a keyword called resource. Resource. And what is the resource type here? The resource type is AWS_security_group. This is a resource type. Okay. Now, if this is a name for future reference purpose, we are going to use this allo TLS. You can give any name. Name is optional. Description is optional. VPC ID is also optional. Okay, three are optional here. Okay, so VPC ID. So if you don't give VPC ID, your security group is created within default VPC. Okay, if you want to create VP security group within a particular network, you have to give VPC ID. Otherwise, VPC ID is not required. And this is ingress rule. Ingress are nothing but incoming rules. Ingress is nothing but incoming rules. And description is optional. And generally from port to port will be same. And protocol is TCP. And CADR block means for whom you are opening this port number. While creating security group from portal, I have given something like 0.0.0/0, right? That is CADR block. And egress rule we are not going to write. This is outgoing rule. Okay. So simply take this script and paste it over here. If you are interested, you can write. But if you write manually, there are chances of occurring spelling mistakes, indentation missing. Maybe that kind of errors might come. That is why, to avoid the time and that kind of errors, better you take it and modify according to your requirements. I am removing this VPC ID. I am removing this description also. It is also not required. Name equal to my group. And here, I am not using IP version 6. We are using IP version 4 only. So CADR blocks is nothing but who can access this port number. So everyone can access. Everyone is 0.0.0/0. This is 22 port number. Here it is also 22 port number. Okay, like this, I am going to define one more port number. Okay. So for one more port number, exactly you can write ingress description. Are you seeing automatically ints are coming here? For 80 port. From port equal to 80 and 2 port. And protocol TCP. And CADR blocks within double quotations 0.0.0.0/0. Tags, it is your wish. SG from Terraform. Okay, that's it. And before you are going to create this, before you are going to execute this script, you have to check syntax, whether syntactically it is correct or not. Okay, to check whether it is syntactically correct or not, there is a command Terraform validate. Okay, there are errors here. Missing attribute and 22 and 23 port number. I missed something. Now it is success. Okay. And in AWS console, yesterday we created credentials, right? Go to IAM. Go to users. This is a user we created yesterday. In security credentials, in the secret access keys, activate it. Okay. Now, so once the syntax, once you prove that it is syntactically correct, you have to generate plan. Okay, to generate plan, so there is a command called Terraform plan. It is going to give complete plan. Okay, so here, what is that? Retrieving AWS account details, validating provider credentials. What happened? Encountered authorization. I think yesterday credentials were not set correctly. Access key, secret key. Is it the correct username? Security credentials. Okay, let us give one more time. Let us configure once again. I think access key, secret key. This is access key. Secret access key. This is a secret access key. Region is US East 2. Press enter. Now, the Terraform plan. Now it is working. Okay, it is a problem of credentials. Okay, so it has shown me that what it is going to do when Terraform apply command is executed. It is showing that it will create a security group with 22 and 80 port number. So let us implement the plan. To implement the plan, so here implementation of plan means really creating infrastructure. Terraform apply, you say auto approve. Auto approve means it does not ask any question while creating security group. Sorry. Approve. Now it is creating security group. See. Now my security group is created. How to confirm whether security group is created or not? Go to. So what is the name I have given here for my security group? In sg.tf, I have given sg from Terraform. Go to EC2 section. Go to security groups. What is the security group ID? It was created FF508. You can search like this. Copy this and search over here. What is the security group ID? F508. It is ending with 508. There is a region. Is the region we have given here? East 1, not East 2. US East 1. This is East 2. Are you seeing here? This one, SG from Terraform. And here if you apply this filter, copy. Are you seeing this one? SG from Terraform. Okay, here if you click on this, it is going to show 2 ports, 80 and 22 port number. Now, here if you look at your current working directory of Terraform, a important file called state file was created. The state file contains all the information that is related to current infrastructure. Okay, in the current infrastructure, we have security group with 2 ports open. Okay, this is all security group information. This is displayed in JSON format. 22 port number is open. Next 80 port number. Okay, every time when we create a resource, so the infrastructure status, the state of the infrastructure is maintained in a file called terraform.tf state file, which is very, very important. Okay, and in the forthcoming classes, we are going to centralize it. We are going to centralize. Okay, because this Terraform file, state file is local to this developer only, right? But in a team, when you are working in a team, okay, so here maintaining this file in a central location is a good idea. Then there is no chance of creating redundant resources. So while working in a team, okay, we are going to maintain this file in a centralized location, which is called as backend. Okay, so how to create backend, that is a different agenda. There we are going to discuss. Now, we have created resource. So with a simple command, I created a resource. Now, if you want to destroy it, generally we don't destroy it, just I am showing. And whatever resources you have created, in single step, you can destroy all the resources. And when you destroy a resource, what happens in the current working directory? Okay, here your state file becomes empty. Your state file becomes empty. Now, if you open the state file, it is empty. It will be empty. Nothing is there here. So whatever state file, state information is there, that is moved to backup file. Here we are seeing one more file called terraform.tf state backup file. Okay, whatever information currently there in state file, okay, completely that is moved to, okay, this backup file. Backup file is created when you destroy the information. Sorry, when you destroy your resources, automatically all the information from state file will be moving to backup file. Okay. So your till this point is everything clear, guys? Any questions? Any doubts?
Yeah, I am good.
Okay. Now, here we are going to create a network. Network means it is a complete full-fledged network. Now to create a network, here. First of all, we are going to design a network. Assume that this is your company network. Generally, every software company will be having its own private network. So they are going to divide that private network into smaller sections called subnets. Smaller sections called subnets. So in each subnet, they are going to launch various types of servers like app servers, web servers, database servers. Okay. And just imagine that, okay, this is a network and I am dividing this network into two smaller sections. So each smaller section, each smaller network is nothing but one subnet. And what are the ranges of these networks here? So every network will be having a specific range. Based on the number of devices, the network size can be decided. Now suppose in this network, I wanted to launch 250 devices. Okay, so 250 means all web servers are there, database servers are there, and web app servers, load balancers, many things are there. Just imagine that the company size, in that company, we have 250 devices. Okay, so for that, how to write networking CADR range here? So we are going to write a condition like this, 10.0.0/24. So whatever you are writing after slash, that is your network length. Generally, when it comes to any network, okay, so the basic entity that we have to discuss is nothing but IP address. So generally, IP address. So how we can define IP address? It is a unique entity that can be, unique entity that can be used to identify a network, identify a resource on World Wide Web. Generally, every IP address, it contains 32 bits or 4 bytes notation. 4 bytes notation. And every IP address contains, okay, it contains 2 sections, okay, 2 parts. So what are the 2 parts here? First one is network part, which is also known as network ID, and second one is host ID. Now suppose I write a like this. When I say 10.0.0.0/24, okay, so here in the second point I told you that the network, the IP address length is 32 bits. So from 32 bits, whatever you are writing after slash, this becomes your network length. That means from 32 bits, so if you minus 24 bits, you will get 8 bits. You will get 8 bits. Yes, so 8 bits is your host ID. You can allocate this 8 bits for your devices. Means since we are using binary system, this is nothing but 2 to the power of 8. 2 to the power of 8 equal to 256. That means here in this 10.0.0/0/24, first 24 bits are fixed. First 24 bits are allocated for your network. Means indirectly this is equivalent to what? 10.0.0.0.x. Here x can be any number between 0 to 255. Why 255? Because here first 24 bits are completely reserved for network. Only the last byte can be used for your host. So if your last byte is used, it is only 8 bits. So if you calculate like 2 to the power of 8 equal to 256. Now here 10.0.0x means, so in this series, what is the first address of network here? The first address of the network is 10.0.0 and the ending address will be 10.0.0.1. 255. This is the ending address. Okay. Anyhow, this is fixed. This cannot be changed. This notation is called as CADR notation. So if you want to know more about networking fundamentals, I can give some sites. Okay. Some basic, because this is very binary calculation. It is fundamental basic elementary mathematics. So if you want to know more about CADR ranges, CADR fundamentals, okay, there are sites. Loads of sites are there. So you can refer any one of these sites. They will explain what is IP address, what is CADR. Okay, why we have to use CADR for network fundamentals. Yeah, there is a site. This is a site. Now this is 256 devices. And when it comes to second example, so in second example, I can write 10.0.0/25. Means first to 25 bits are allocated for network. Means if you say 32 minus 25, that is equivalent to 7. So here 2 to the power of 7. 2 to the power of 7 equal to how much here? 128 only. 128 is small network. Then /24. Here the first address starts from 10.0.0. And it ends with 10.0.0, 127. This is example 2. Always remember, as a CADR number is increasing, you will get small network. And in example 3, if I say 128 by 25. Here also same calculation, 32 minus 25 equal to 7 bits. And what is the first address and last address? Can you tell me, guys? Can anyone tell? Here 128 is the starting address. 10.0.0.128. The ending address will be 10.0.0.255 is the ending address. Because here clearly we are mentioning that 128 is the starting address. So in our first example, this is a CADR range for 255 devices. Second example, 128. Third example, 128. Total it is 256. So here we can apply this to our network design. Here my whole network range is /24. And for this small network, I can give 10.0.0.0/25. And for this small network, I can give 10.0.0.128 by 25. And here this is my subnet 1, which is also called as public subnet. And here this is, I am going to call it as private subnet. Okay, so generally in the public subnet, we are going to launch web servers. In private subnet, we are going to launch app servers and database servers, which should not be exposed to outside persons. Okay. Now, so if you launch a virtual machine within public subnet, it will get a IP address from 10.0.0.0. Okay, in our example, in example 2, starting address is 0, ending address is 127. .0.0.127. And here, if you launch a virtual machine in this second subnet, it will get IP address in between 128 to 10.0.0.120, 255. But here for every platform, cloud platform, it will take 5 addresses. 5 are reserved IP addresses. Okay, so you can conclude that every public subnet and private subnet, private or public subnet will get only n-5 addresses only. But here we are expecting 127, right? 128. But 128 minus 5, we will get only 123 addresses only in each and every subnet. Okay, so how this will be happening? And so for this, AWS reserved IP addresses. Not only AWS, every cloud is going to take first 5 addresses are reserved IP addresses. Just have a look here. Here these are the reserved IP addresses: 0, 1, 2, 3. First 4 addresses and last address. It can be either main network or sub network. 5 addresses will go. First 4 addresses and last address will go. So just for the sake of reserved IP addresses, refer here. This is not specific to AWS. Same thing is also available in Azure Cloud. Same thing is also available in GCP. For reserved IP addresses, refer here. So what are these addresses? First 0 is network address, 1 is it is router, 2 is reserved by AWS, 3 is future use, 255 is broadcast address. So here you will get only 123. In public subnet or private subnet, you will get only 123. Now this is a public subnet and private subnet. Generally here we are going to launch all web servers in public subnet. Let us see. Web server clipart. Did I copy it or not? Copy this. Only web servers will be launched in public subnet. And database servers are launched in private subnet. So because your web servers must be accessed from internet. This is my web server. And this is my DB server. And internally, my web server can communicate with DB server. But outside people cannot access this database server directly, because database server will be having some sensitive data, that cannot be exposed to outside person. So suppose this is my web server. Let us see browser logo. Browser clipart. Suppose this is my end user system. End user means you and me, who are going to access application. This is my end user system. And this is my end user browser. That means from anywhere, they are able to access the system. They are able to access this web server. This can be either laptop, your laptop, or PC, or even from mobile phone also, we can access the application, right? Now any end user will be able to access web server's application. But my end user will not be able to access this database server. This is not possible. There is no direct route to this database server. And one more thing, every VPC, okay, this is our company, this is our private network, and every VPC, generally it is attached with a gateway. Gateway is just like our router. Okay, so in our home, when we don't have router, we don't get internet. In AWS also, okay, once you create network, okay, VPC, okay, that network or VPC must be associated with a gateway. Then only this VPC will get internet. And every subnet will also have a route table, because the traffic will be redirected through this route table. And this is a route table for this public subnet, sorry. And this is a route table for this public subnet, and this is a route table for this private subnet. And this route table is connected to internet gateway. But this route table is not connected to gateway, because this is private subnet. Whatever servers that are launching in private subnet should not be exposed to outside people. Only the servers in the public subnet should be exposed to outside people. And this is a route table for, this is public route table. And it is a route table for your private subnet. Let us save this document. Okay, now in this network, so I told you that /24 is your CADR range. Means, so when you create a virtual machine in any subnet, it will get an IP address from 0 to 255. So here the 32 minus 24 equal to 8. Here, since we are using binary system, it is 2 to the power of 8. 2 to the power of 8 equal to 256. And the starting address of the network is 10.0.0.0.0. And the ending address will be 10.0.0.255 is the ending address. But of course, 5 addresses will be reserved. 5 addresses will not be allocated. First 4 addresses and the last address. Now, just by looking at the diagram, can you tell me what is the difference between public subnet and private subnet? Did you observe any difference between public subnet and private subnet?
Private subnet is internal to the organization itself, whereas public subnet, we can have access from outside.
Yes. Okay, you are right. But is there still any other technical difference? Technical point of view. Can you differentiate between these two? Here, public subnet's route table is connected to gateway. Okay, since gateway is a public one. Okay, so if a route table, if a subnet's route table is connected to gateway, okay, that subnet is called as public subnet. And the servers that are launched in public subnet can be accessible from internet. And if a subnet's route table is not connected to gateway, such subnet is called as private subnet. And the servers that are placed in such subnet are not exposed, okay, to outside people. Okay, so let me write the definition. So when you write the definition, it will be very clear. Public subnet first. So if a subnet's route table is connected to internet gateway, such subnet is called public subnet. Generally, we launch or place web servers in public subnet. The servers launched in public subnet are exposed to outside people and they can be accessible from internet. This is the actual definition. This is a functionality of public subnet. Now, when it comes to private subnet, what is private subnet? Reverse. If a subnet's route table is not connected to internet gateway, such subnet is called private subnet. Generally, we launch app and DB servers in private subnet. The servers launched in public subnet are not exposed to outside people and they cannot be accessed from internet. Okay, so we are going to launch app servers and DB servers. Okay, in private subnet because they should not be exposed to outside world. They should not be exposed to outside world. Okay, this is our complete design of network. Okay, so it can be small or large in some other companies, but I have taken one simple 256 is a total size and each subnet size is 128. Okay, so we are going to implement this network in tomorrow's session manually first. Okay, I will show how to implement this network manually, how to create VPC, subnets, route table, gateway. Okay, and we are going to log into server. Okay, and let me write the steps. What we are going to do tomorrow in tomorrow's class. In our next session, we create this VPC. VPC is nothing but virtual private cloud. Virtual private cloud. This is also called as network service in AWS. You create this VPC manually from console first. Without knowing console activities, directly we cannot write automation script. Okay, so what are the steps that we are going to perform? Create a VPC with a CADR 10.0.0.0/24. And our second step will be create a gateway. Which gateway is it? Is internet gateway. internet gateway and associate that gateway to the VPC. Third step is create a public subnet or subnet for public with a CADR 10.0.0.0/25 and create another subnet for private purpose, private use with a CADR 10.0.0.128/25 and create a route table for public subnet and associate it with public subnet and gateway. Sixth step is create a route table for private subnet and associate it with private subnet. Don't link up with the gateway. Again, if it is linked with the gateway, that becomes a public subnet. Okay, next last step is create a server in public subnet and test connectivity from our laptop. This is succeeded because it is having route to gateway, right? So we are able to log in into the virtual machine because okay, so there is a route between our laptop to internet gateway because public subnet is connected to internet gateway. This is succeeded. But when you create a virtual machine in private subnet and in the same way create another server in private subnet, in test connectivity and test connectivity from our laptop. This is failed because directly I told you that directly there is no route from our laptop to private subnet, but still we can connect. How you can connect? From web server. Okay, from login into web server first. From web server you can login into this private server, DB server. Okay, how that is possible? Tomorrow we will discuss everything. Tomorrow's session is very interesting. Okay, this is failed. Direct connectivity is not possible, but indirect connectivity means you have to go to web server first. From web server you have to log in into DB server. That is possible. Tomorrow we are going to see all these steps manually, all these 8 steps. And one more interesting thing, provide internet connection. Internet connectivity or connection to the private subnet. Generally, private server should get internet from outside people, from internet. Okay, it should not be accessed. But this DB server sometimes requires patches, right? Patches, upgradation. So in that case, DB server should get internet, one-way connectivity. But outside people should not be able to access. Okay, how to do that? So for that in AWS, there is a advanced concept called NAT gateway, which is very interesting. Okay, using NAT gateway, we can provide internet connection to private subnet servers. NAT stands for Network Address Translator. This we are going to implement practically in tomorrow's class. Okay, so once we write once we create this network manually, in Monday's class, we are going to automate this. We are automate complete network creation. Is it interesting, guys?
Yes, Shiva.
Is it clear so far?
Yes, Shiva. I think like we have to practice. We have to go through the video one more time. Yeah.
Yeah, go through the video. Okay. So if you have any questions, you can ask me. Otherwise, I will stop it for today. Tomorrow, don't miss tomorrow's session, because tomorrow I'm going to show complete network creation. Okay, in AWS. Then in Monday's class, okay, we will write automation scripting, automate this process.
Sure, Shiva. Yeah.
Okay, guys, I'm stopping the session. Tomorrow we meet again.
Okay, sure. Thank you.